So thank you guys for being here today. This is the second day of the Planning Your Research series that I'm doing on the research process from question to analysis. So my name is Heather Chancellor McIntosh, for those of you who did not know me. So thank you for being here today. The goal of this series is to be skills-based and as interactive as it possibly can be. I will be talking at you some, but I'm hoping that we'll be doing some stuff on the computer as well as kind of shouting out answers at me, so feel free to do that. So you should have received a packet via email that has some of the slides in greater detail, and then also the data collection sheet that we'll be looking at today. So if you do not have that, you will need it. Shelly in the back can probably get that information to you as quickly as possible. We won't need the data collection sheet until a little bit later, but we'll still need it. So, like I said, this is meant to be skills-based, but I certainly don't expect for you to leave this series and have a mastery level understanding of any one of these concepts. I'm hoping that it's either a refresher to some basic knowledge you've already received, or maybe it's your first exposure to the information, but again, at a very basic level. So I still encourage you to reach out to your resident statistician or person who's trained in that area to help you out with this stuff. But I think that having baseline information on this is really helpful. So, like I said, my name is Heather Chancellor McIntosh, and I work for the Office for Research Development and Scholarly Activity in the School of Community Medicine. So I've been with the university since 2012. My graduate training is in research, evaluation, measurement, and statistics. I also just want to say a couple of quick things. So this is meant to be very informal. If you need to get up or leave early or grab more food, please feel free to do so. And I'd also like to thank Shelly for putting this all together again, all the administrative work that goes into it and all the emails, and then the Office for the VPR and the College of Arts and Sciences. They paid for this, so thank you for the food. Okay, so we will get started. So today the focus is, I should say, if you weren't here yesterday, I love dogs. If you were here yesterday, then you know that, so there will be more dog pictures sprinkled throughout this, so get ready. But today the goal is a couple of things. Today we're going to focus on identifying the right data and defining the variables, as well as the importance of consulting a statistician really as early as possible in the data phase of your project. So we started out yesterday by talking about the scientific method and using that as your guide for the research process. So we worked on bubbles 1, 2, and 3 yesterday, and today we're kind of moving more toward the prepping the data, identifying what data you're going to collect, getting it ready for analysis, and then tomorrow we will focus on the analysis and some interpretation. Tomorrow we'll also be working in Qualtrics a little bit. So just a quick review of yesterday. I gave some quick tips on how to develop a research question. I won't spend a lot of time on this since we went over most of this yesterday for the entire hour. But basically, to get your thoughts down on paper, to get all that information out so you can really see it in words, and then talk it over with colleagues, turn to the literature for what's been done previously to your study, and then really refine, get that question as succinct as possible. So, and then the last point I have here is that your question should really drive your whole study. So everything should tag back to your question. Having a strong research question is really important. And then these are the example ideas. We didn't get through all of them yesterday, and I don't suspect we will today, but we'll be working off this first bullet point, which the general concept was volunteers, sympathy, contact hypothesis, and attitudes toward homelessness. So this is just some refresh from yesterday. Pretty picture for you to look at. This is Pikes Peak. So I took that picture, pretty proud of it. So this kind of signals that we're transitioning a little bit, so signal to me to transition. We're going to talk about research design methods, but for not too terribly long, because next month's series is totally on research design methods beyond the randomized control trial. So I just wanted to point out that in the research process, you will be determining what methods you're going to be using. And there are a variety of methods to use. So case studies where you have an N of 1, chart reviews for those of us who are in medicine who do a lot of retrospective chart review. Focus groups is a qualitative method, interviews, and then randomized control trials, and then surveys. So this is certainly not a comprehensive list. This is just some of the main ones that people use, especially here on this campus. So I just wanted to highlight that. If you're interested in learning more about research design methods, I encourage you to sign up for the series next month, which is actually led by Jody Worley, who's here today. And I believe it's, October 18th, 19th, and 20th. Is that right, Shelley? But it's not in this room. So sign up if you're interested in learning more about that. Okay, so these are some example research questions that I just wrote up last night for the purposes of us getting through today's presentation. So we'll be talking about these questions in terms of identifying the constructs and variables that we'll be using and what types of variables those will be. These are just basic questions that I thought would be easy to go over, and then tomorrow we can hopefully apply these to the SPSS database and run these analyses and interpret the data. So 2 questions here, and then just a couple of more basic questions here. Okay, so when you have your research question written out and you're ready to start identifying what your variables are, first you look at your question and you think about what are the components of your research question. So here I have this first bullet as operationally defined constructs are transformed into variables. So a lot of the things we study, especially in social behavioral sciences, are these kind of abstract constructs like hope and grit or various attitudes towards something. When you say those words, you don't instantly think of how I'm going to measure that information because they seem kind of nebulous, right? Like how do you measure grit? Or how do you measure self-esteem or something? So first you have to operationally define those constructs, give them meaning in the scientific world. So the previous series in August was pretty much about that and then identifying measures that you can use to measure these constructs. So for today's purposes, we're going to assume that that has already been done. So we've already looked at our research questions and identified the constructs of interest. So for this first bullet point, can anyone identify what they think we might be trying to study? Sympathy. Yeah, so we're interested in sympathy, thank you. We're interested in the relationship between sympathy and attitudes. So those are the constructs that we're working with. So for that example, we'll say that we've turned to the literature and found how do we measure trait sympathy and attitudes toward the homeless. And we did our search through the library and found that there's the trait sympathy scale that's used very frequently and has good psychometric properties. And then we've also found an attitudes toward the homeless inventory that's used quite often in homeless literature. So once we've identified those measures, then we have an idea of what our variables are going to be. Now we know that those are our constructs of interest. We know how to measure them, so they're now our variables. So now we have a working idea of how to develop our survey by including those scales. Does that make sense so far? Good. Okay. So in this second bullet here, I've already said, look to the literature for existing measures. If you're interested in measuring something, someone has likely already developed a way to measure it. So I would turn to the literature, try to find the gold standard for that particular construct, and also try to find ones that are free. If you find one, sometimes you have to ask the author for permission to use it. And I've actually done that and have been very successful in doing that. You just email the corresponding author, and they were actually delighted to have me use their scale. So they wanted to know about my research and all of that. So pretty easy to do, but like I said, look and see what's been done before you. What are the gold standards before you go out and try to develop your own scale for something, because that's a lot harder than I think people might realize. So, okay, so once we've started to identify the components of our question, like I said, we can start with survey development and putting the scales or whatever variables we're using into our survey. Okay, so what is a variable? Does anyone have a good working definition? Okay, so the variable, or the definition I have here is a variable is any trait, factor, or condition that can exist in differing amounts. So is everyone fairly comfortable with independent and dependent variables and kind of the difference? Okay, well good, we won't have to spend a ton of time on them then. So an independent variable, I'll go ahead and just go over it. The basic way that I think about it is it's the variable that's doing, kind of in an oversimplified term, it's doing the acting upon, or it's doing the influencing. So this definition here, behavior or characteristic under the control of a researcher believed to influence something else. So it's considered to be the X variable. And then I've included some synonyms down here because I find that when I'm working with different groups, I will use these synonyms a lot more often than I say independent variable. And I think I take for granted that not everyone is super comfortable in that language. So instead of saying, well, what's your independent variable, I might say, well, what's your predictor, or what's your grouping variable for that? So I just put those on there in case you're in a meeting and you hear those terms. The ones at the bottom are really used for specific analyses a lot of the time. So, but factor and predictor are used pretty often. I know I use them a lot, so I just thought that might be helpful. Okay, so then a dependent variable is really just how it sounds. So it depends on something. It's the one that is being acted upon, or it's being influenced by something else. So I have the definition of it here. So a change or difference in a behavior or characteristic that occurs as a result of the independent variable. And it's known as the Y variable also. And then I've listed again some synonyms here. Outcome, criterion, effect. Those are words that I use pretty frequently when I'm referring to a dependent variable. So in working with these definitions of independent and dependent variables, in these two questions, can anyone identify what they think is the independent and what they think is the dependent variable? Right? And so the dependent variable is the volunteer attitude. So we're thinking of the type of volunteering as having some influence on the attitudes toward the homeless, right? And similarly with this bottom bullet, so the independent variable are these various demographic variables, and I didn't list them all out. But I thought we could look at gender and race and that kind of thing tomorrow. And then again, the dependent variable is the attitudes toward the homeless. So everyone feels good with independent and dependent variables. Okay, great. So what about types of variables. Is everyone comfortable with the types of variables that you use? So nominal is the most basic level of a variable. It's also referred to as categorical, and it is used to measure qualitative differences. So an example would be eye color or race or ethnicity. So something where the numerical value is really a placeholder for the qualitative difference in the variable. And then the ordinal level is where the data are ordered or ranked. So first, second, and third, high, medium, and low, that kind of thing. Okay, so interval, also known as continuous level data, it's a level of measurement where the distance between the scores are uniform, but that the 0 point on the scale is arbitrary. So a good example of this would be age. So the difference between 30 and 31 is the same as 31 and 32, right? Time of day, so the difference between 2 o'clock and 3 o'clock is the same space between 3 o'clock and 4 o'clock. And then ratio has all the properties of interval level, but then the scale has a true value of 0. So a really simple one that comes to mind is number of children. So you can have 0 kids or 1 kid or 3 kids or 9 kids, but 0 means something. You have 0 children. Okay, so everyone feels good with the levels of measurement here. So in these example questions again, we've identified the variables. Does anyone know what they think the level of measurement may be for these variables that we identified earlier? Okay, so type of variable, type of volunteering is going to be nominal. So it's a type of something, they're categories. And then volunteer attitudes toward the homeless will be continuous because it's a scale. We talked about using the attitudes toward the homeless inventory. So that would be treated as a continuous level variable. So this is really important in understanding what your research question is and then identifying your variables within the question and knowing the level of data that you're working with, because this impacts the level of analysis you can do. So these are really basic. Probably everyone recognizes all of these tests that I listed up here. You've done them, I'm sure, before. I included them so you would know exactly what they are, but this is certainly not a comprehensive list of analyses. But really what I wanted to highlight on this chart here is the last 2 columns, the independent variable and the dependent variable. So when I said that understanding what level of data you're working with is really important, this is why. Because your level of analysis is reflected based on the type of data that you're working with. And there's, it's a real bummer whenever I'm working with people and they think that we're going to be doing an ANOVA or some kind of more advanced statistic, but it turns out that they only collected nominal level data. And that happens a little bit more frequently than you would think, but people just don't think about the level of measurement that they're working in, and that really does impact the type of analysis you can do. So if you just have nominal level data based on this chart, you could do a chi-square. And then you can see where your nominal independent variable is to be used, and then interval or ratio level dependent variables. So I just wanted to highlight that that's really important when you are making those decisions about what variables you're going to use and then how you're going to measure them, because that has an impact on what you can do with the data. And like I said, it can be really frustrating if you've gotten to the end of your study and think you've been working towards something, but it turns out that you didn't collect the data the way you thought you did. A really simple example of that is age. So age should be treated as a continuous variable, but oftentimes people want to put categories of age on a survey. And I haven't quite figured out why. I don't know if it's because people don't want to ask someone's age and think it might be rude, but when you have a categorical version of age, so 18 to 24, 25 to 34, that kind of question, you never actually know what your respondent's age is. And so you can never get a mean age on your surveys of your respondents. That kind of stinks, not being able to know what the average age was or what this respondent's actual age was. If you collect that data at the continuous level, you can always categorize after the fact. So if you have someone's age, 30, 45, 18, and you have a list of 100 surveys and you've collected all of their ages, you can categorize when it comes time to do the analysis, but you can never work backward. You can never take that categorical data and say, okay, well, what is the age of this one particular person? So, and there's a big difference between 18 and 24 and 25 and 30. So that's just a really small example, but I do see that a lot whenever I'm asked to consult on survey development. It's one of the first things that jumps out to me is if age is in categories. I really like to have it continuous because I don't think it offends anyone. They'll not answer it if they don't want to, but for the most part, people are just going through and filling out their surveys. So I say put it on there as a continuous level variable. What kind of level of measurement do we think the Likert scale is based on these definitions? Yeah, so like none of the time, some of the time, all of the time. Have you seen those in a survey before? So by definition, those are ordinal, right? But feel free to chime in over here, you guys, but the scientific community has kind of come together and decided that we're going to treat those as interval level data and that we're going to assume that the differences are the same. Because we treat all Likert scales as interval level, right? It's a continuous data. You can get a mean score from a scale, but really by this definition, it would be ordinal. But there's actually a lot of literature out there on how Likert scales should be used, if they should be treated as a continuous variable. I say yes, because otherwise it'd be really difficult to measure some of these abstract constructs like grit or hope. How would we measure hope if we couldn't use a Likert scale? It would be a little bit more difficult. So just something to keep in mind whenever you are developing your surveys. Just have that in the back of your mind. I mean, it won't change your analyses necessarily, but it's good to think critically about that kind of stuff and think, that's weird. Okay, we won't stare at this picture anymore. Okay, so power analysis. We're not going to spend a ton of time here because this could be talked about for a really long time. But doesn't everyone say this? Like, do we have enough power for the study? Are we going to be underpowered? Everyone wants to know that, right? They want to know what their sample size should be and if they're going to have enough participants in their survey. So I just want to put this up here and I'll go over what G-power looks like. So is everyone familiar with power and know kind of what power is? So it's the ability of a significance test to identify if there's a true research finding. So that if you're finding, you want to make sure that your finding is not just due to chance or error, right? So I use software called G-Power to compute like a sample size calculator. So you can do a couple different kinds of power analyses. You can do an a priori, which is certainly preferred if you can. So it's doing the power analysis, getting your sample size on the front end. So when you go into your study, you know how many people you need to have in your study. That's helpful. And then you can also do a a post hoc, if you've completed your study and then you did not get the results you maybe thought you were going to get based on your hypothesis, and you wonder, well, was our sample size too small? Then you can do a power analysis after the fact to determine if you need to add more people or enroll more people. So I believe this link is in the handout, but I just wanted to show you guys what it looks like. It's just like a print screen of it. So I first want to say, there's a lot of words here, but so when you are ready to figure out what your sample size should be for a study, and you go to your statistician or you go to whoever is working with you on the data side of things, and you say, well, I need to know how many people I should enroll in the study. Well, one of the first things they're probably going to ask is, do you have a research question, that kind of thing. But also everything that we've been talking about leading up until this point is important for a power analysis or for your sample size calculator. So we have to know what your variables are. We have to know what level of measurement you're using, because that leads to what analysis you'll be doing. And when using this software, which you don't have to use, I believe there are other softwares out there, and some people might calculate this by hand. I'm not one of those people, but I find that this is just easier. But if you see the test family up at the top left and the statistical test, all of those things you have to know. And that comes from all of the stuff we've been talking about leading up until now. So, like I said, your research question, your level of data, and the analysis you're going to use. So I certainly don't expect anyone to leave here today and go download G-Power and start working in it by themselves. But I think it's good to have this knowledge. It's good to know what goes into making these decisions when you're working with a statistician or you're working on the data side of things, because what seems like little decisions along the road, they all impact each other. So they're all really important. You know, what your research question is, how you're going to, when you identify your data, what data you're going to use, how you're going to measure it, what analysis you're doing. All of that's really important for really the integrity of the study, but then also when you go to write up the results and you want to submit to a presentation, and whether it be poster or oral, or you decide to do a manuscript. So yeah, so another picture. I won't ask if you guys like this one because I love this picture, so I don't care. That's my dog Kendall. That's at Woodward Park, and I thought that was so serene. She's just right in line with the tree. But anyway. Okay, so coding data. So now we've collected our data. We're skipping some steps here because we obviously can't collect data in this 1 hour. But we've collected the data. We're ready to prep it for entry into our software to analyze it and then interpret the data, right? So the next couple of slides are some tips for how to code your data to make it as easy on you and on your stats person as possible. When coding your data for your own analysis, or if you're sending it off to someone to do the analysis for you, there are some helpful things that you can do, like I said, to make it easier on you or on the person who's doing the analysis. So starting off with the lowest level of data, nominal or categorical level, like I said earlier, the numbers are really placeholders, right? So they're just a numerical value that is holding the place of whatever the qualitative difference is. So I did eye color up here, for example. You could do eye color as blue equals 1, brown equals 2, green equals 3. Or you could do 7, 8, 6. It doesn't matter, was the point I was trying to make there. Just as long as you know what the codes are, that is all that matters. So, and then the The next two bullets here, they really go together. So standardized coding for continuous data, and then organizing values in a positive direction. So if you have multiple Likert scales in your survey, or if you have multiple demographic questions and you're trying to decide how to code them, keeping everything standardized. So if you're going to start at the top, say you have education level or something, and your options are like high school graduate, college, that kind of thing, starting at the top with one and going down and continuing on with that standardization when you're coding your data for ease of understandability, right? So you can quickly look and say, oh, well, that's the first option, so it's a 1. Or, oh, that's a second option, so it's a 2. That kind of thing. And then organizing the values in a positive direction. So, we think of something like strongly disagree as being negative more often than not. So starting out as a 1 and going up in the values when it goes from strongly disagree to strongly agree, or none of the time to all of the time. So going up in that direction. It makes it easier to interpret the data later when you are in that phase. Does that make sense? Pretty simple. And then again, like with yes and no, so no being the absence of something, so that being a 0 or a 1 or a lower number, and then yes being the presence of something, so that being the higher option. So like I said, just some tips for coding your data for making it easier on you if you're going to be the one analyzing, making it just more intuitive, or for the statistician if you're asking someone to analyze the data for you. So at first glance, this is a really basic sheet that I just made for the purposes of this class or this presentation, but it should be easy to read, right? So subject, and then I think gender, age, that kind of thing. So hopefully it's easy to read if you are looking at it right now. I'm going to go ahead and pull it up. Okay, so easy to read. You can look over and quickly see you've got your subject, gender, age, race, and then what looks like probably some kind of scale of some sort, and then a total scale here. Okay. And the next thing is having a code book or some kind of key so you know what the numbers mean, right? So here I have the key for it. So I know what my values mean whenever I go to interpret the data. So if I look at subject 1, I know that the gender is 1 and the race is 1, and I just used very basic demographics here. But so I know it's an African American female who is 26, right? Because the whole row is the same. This row is subject 1, and this row is subject 5. Everyone's pretty comfortable with this? Okay. The other thing is making sure that you use numerical coding. So not having the letters in the code sheet, because that doesn't help you. You'll have to just transform that into a number later. So when you are going from your survey to your data collection sheet, you have your values already assigned to your responses. Okay? So that makes it really easy on the person who's doing the analysis, because then they don't have to figure out what you were trying to say if they don't have the key in front of them. The last thing is having your data collection sheet be compatible with whatever software the statistician will be using to analyze the data. So I had this compatible with SPSS because that's what we'll be working with tomorrow. So in doing that, all of my labels, so subject, gender, age, race, and the questions, they're all left aligned. There's no spaces because a lot of software systems won't take spaces in the variables. So that's why it says question 1 underscore LS. So the underscore is a placeholder for the space. If you do this, you will be able to transition this into SPSS pretty seamlessly. So, so doing this work on the front end is really important for just a more easygoing process. Yeah. So as far as formatting the Excel spreadsheet, yeah, no, I didn't do any extra formatting for that. I just made sure that my headings were left aligned and I didn't have any spaces and that everything was standardized. And then, so for the total LS here, I had that scored by Excel, but you wouldn't even necessarily need that column because SPSS would do that for you.
That's just a sum of the...
Yeah, that's just a sum of their responses, exactly. So there's like a total scale score. Okay. So this exact document can be exported into SPSS and then you already have it there and you don't have to enter the data in. So has everyone done that before? Okay, so this is like a really advanced class. I don't even know. You guys are awesome. Okay, so we're going to do it anyway because it's on my list of things to do. So go back to okay, so we're going to go ahead and transition from the Excel spreadsheet to SPSS so you have it there and we can do some analyses with that data tomorrow. Oh, okay. So you're going to open SPSS if you have it on your computer. And you'll need the Excel spreadsheet saved to your desktop or wherever. There we go. Okay, does everyone have SPSS open? Who wants it open? Or it's loading. Yeah, it's kind of slow. We good? Okay, so in order to do this, it's really simple. It's like 5.5 steps, really. So you'll go to File, the top left, and Open, and then Data. And it'll pull up the dialog box. So I have mine saved to the desktop, so I'm going to scroll up and make sure the desktop is there. Well. What's going on? Is everyone's pulling up if it's on their desktop?
You're actually looking for the dot saves. So in your file.
Oh, you're right. I'm sorry. Thank you. That's in my notes. Make sure that your file is Excel. So thank you, Chan, for saving me. That's literally my next line. So should have read ahead. Okay. So yes, you need to make sure that your files of type, since it's an Excel document, yes. Yeah, so you can do copy and paste if you want to. I find that it does leave more room for error whenever you're copying and pasting, because sometimes if you don't have the settings right in SPSS and you have a blank space in Excel and it treats it as a blank, sometimes when it transfers to when you copy and then you paste it into SPSS, it'll autofill with a 0. And you have to go in and make sure that your settings are set correctly, because if you didn't intend for it to be a 0 there, there's a big difference between a non-response and a 0, right? Because then 0 is affecting your scores. Okay. So you can do that, and if I have small data, sometimes I will do that, or if you know, I'm entering data on both SPSS and Excel or something, I'll copy and paste back and forth, but this will do it instantly. So you'll click on the copy here and then open. And basically what this dialog box is saying, it's asking you, do you want the first row that was in Excel where it said subject, gender, race, age, do you want those treated as your labels on the variable view? And the answer is yes, you want to treat those as your labels. So you just click OK, and then your data is there. And then you can go in and tomorrow we'll do some basic analyses with this data. So especially if you have a bigger database, then it's easier than copying and pasting. If it was set up correctly, that's the thing though, making sure that if you're not the one doing the data collection sheet, making sure that you're communicating with that person so they know to create the Excel sheet how it needs to be compatible with the software. Okay, so it sounds like everyone had already done this before, so that's awesome. This will save you some time, and then you have your data here in the data view, and in the variable view, you have your variables listed here, and then you can label, you know, if this is a certain question, you can write off the question if you want to, and then add in your values, and we'll talk about that more tomorrow, but I'm getting the sense that everyone's done all of this before, so it will just be a refresher, and maybe there's something that I do a little bit differently than what you do. So I should have said that at the beginning. This is the way that I do things, and there are certainly many ways to go about doing this process. So whatever works for you is great, but I always find that sitting and hearing what other people are doing, or if they have a trick or something, it just makes me a more well-rounded, person here. So anyway, so yeah, I'll be going to Jody's next month because I want to learn what Jody has to say about the research design method. So anyway, I think we're about out of time. Does anyone have any questions?
I have a question.
Yeah, so I don't use 999. I'll just leave it blank if it's a non-response. I just don't fill in the response space, because if I put 999 in there and those numerical values mean something, then yeah, you have to either tell Excel not to include that in the calculation, and then when you transfer to SPSS, you have to make sure that those 999s are not impacting your data. No, it'll just be treated as missing data. So if you don't have a response there, if it truly was missing, someone didn't fill in that space, then I leave it blank. Okay, so today was really about the variables and data side of the research process. So everything we went over today, like I said, I think everyone has done this before, so it sounds like you have your own way of doing it, but I appreciate you coming out today and hearing about how I do things. So I still recommend consulting a statistician on your project. There's a ton of knowledge on this campus, and there's really no reason to work in silos and do everything by yourself. So build your research team and ask people to help you. I think you'll find that it makes the process a lot easier and more enjoyable. So if you,
Is there a 1-800 call statistician?
yeah, right, okay.
Yes, it's 660-318.
Yeah,
Starts with 918-660.
yeah. So that's a great question, though. If you are in the School of Community Medicine or in the College of Public Health, there is the Office for Research Development that helps a lot with data analysis and interpretation and the whole research process. If you're in a Norman-based program, then you can still contact me and I can help connect you with someone. I'm happy to do that because I really believe in promoting the research, mission of the school and us all working together. So that's not saying that I will necessarily do your analyses, but if it's a project I'm interested in, I might want to help. So, so thank you guys for coming out today. I appreciate you being here, and I think we've gone over by a minute, so I apologize if you have to get somewhere, but thank you for being here. And get more food, because I think there's more.